Hey guys, this is Jeffrey. I'm here with a video on aliasing as well as how parameters are passed by reference and by value, and I'll also cover a little bit of wrapper classes in here as well. The entire topic is fairly simple, although the AP test loves to belabor the point and make it sound confusing, but it's really not that bad. So the basics of this is that there are two ways of passing parameters to a function or to a constructor. You can pass by reference and you can pass by value. When you pass by value, you are making a copy of whatever the parameter is and sending it to that function. If the function modifies that copy, it has no effect on the value of the variable you sent. At that point, the one that's received by the function is simply a copy. It's only seeing the value of it, it doesn't see its location in memory. If you pass something by reference, you're passing it the location in memory of the item of the parameter, and it'll always be an object. So that function is able to modify the object, but note that the reference itself is passed by value, which means that that reference can't be changed. So if you pass an object to a method, that method can change the object by calling its methods, or it can assign, if it's an array, different values to its elements, but it can't give it a new point in memory. It can't say this is a new object of that type. It can't redo it that way. So I've just got right here a brief example to highlight all of that, how it works. So the first and easiest point, all primitive types, Boolean, int, double, character, etc., are passed by value. So if I declare an int here called a and give it a value of 7 and pass it to this int function, you'll see down here, this is going to still print out a value of 7 when I say system.out.println a, because even though right here it's accepting that integer and assigning it to a new value, this is a copy. So right here s is only a local variable. It doesn't impact the value of the real parameter or the real integer right here, which is going to be the same. If you wanted it to impact that value, you'd have to do an explicit assignment such as a equals int function 7, and you would have this have a return type such as int right here. If you rewrote it to do this, say return 42, and then went up here and you said a equals int function 7, that would print out 42, because you have to do an explicit assignment in order to have the value change. But for the most part, the value is not going to change unless you have some sort of assignment like that. So the next thing to point out is when you use a wrapper class. I mentioned before that objects are typically passed by reference. This is only kind of the case for a wrapper class. A wrapper class is a class that represents a primitive data type as an object. So the integer class represents an integer. It can be declared as integer name equals new integer 7, or you can just say 7. It doesn't matter which way you do it. But the big thing with wrapper classes is that when you pass a, for example, a integer as the object, it actually in the method is converted to the primitive type int. So even though you think you're passing an object, what's really happening is you're passing by value. You're still passing the integer, this 7 right here, to the function. So when I run this, you'll see that for all of these references here, all of these are in the function reassigning a value of that integer, the integer object or the int, and it's never working. It's always coming back with the original value of 7 because it's passed by value. You're passing the value of this integer, and the method can't change that value. It only has a copy of the actual variable right here. It doesn't have the actual variable itself. So that's about it. The only other thing to know for this sort of thing, it's useful to just keep in the back of your mind, is that if you have in an integer object, that integer object is interchangeable with the integer primitive type. For example, you can, for the most part, any method that will accept a integer primitive type, you can also pass an integer object, and Java automatically does the conversion in the background. That does take up some more CPU, but it's a really nice feature if you have to do it. Like if for some reason you have a primitive type and you want to pass it to integer, you don't have to do an explicit conversion. It just does it for you. So that's fairly nice. The next big thing, strings are the oddball in terms of objects. They're a lot like wrapper classes in a sense, that they are passed by value also. You can't reassign the value of a string when you pass a string to an object. So if you look down here, when I call string function, it tries to assign s to changed, but s once again is only a local variable, and in the end the actual string b keeps its value of default. That works also if you have the string be called an object. Object is the universal superclass in Java. Basically, everything automatically extends object. So if you convert the string to object and pass it to the function, and then try and print it out again, you still will not be passing by reference. You'll still be passing by value in that scenario. That's something not even the AP test would probably test you on, but good to know. The next thing, if you have every other object, including arrays, are going to be passed by reference. So what that means is, when I send this array object to a method, this method sees the location in memory of the array, and then uses that memory and location to create an alias of that array. An alias is an alias of an object is something of the same type that's given a different identifier but points to the same location in memory. In other words, it's the same thing. So you'll see here, if you pass an integer array to a function right here, array function, you're passing it, the parameter that's accepted is an alias right here. If you reassign that value, in this case s, to a new value, that makes a new location in memory, and this is no longer an alias. So any changes you make are not going to impact the actual array. But if, for example, you took that same string array and you pass it to another function where you are using the same array, the same space in memory, it actually will change the contents of that array. So you'll see here, when I ran this, initially it was unchanged when you only called the first string array function. But when you call the second one, the one that's not creating a new location in memory, it does succeed in changing the values. So that is where passing by reference comes in. In this case right here, this string array was passed by reference. That reference was used to make changes to the actual object, and those were visible in the other parts of the code. To reiterate, in the first part, it was passed. It was still passed by reference, and this right here, you still could have used it to change it, except for the fact that you changed it to reference. And since the reference itself is passed by value, it's only a copy of it. If you change that reference, it has no impact on the actual object that you started off with. So I hope that helps kind of clear this up. It's really not too confusing of a topic. If you understand the idea of passing by value and reference, it's pretty simple. Just try and remember, in almost every case, primitive types passed by value, objects passed by reference. There are a few weird exceptions, but those won't come up too much on the AP test. Just probably one or two multiple choice questions will be about it. So yeah, thank you guys for watching, and goodbye.